Okay, here's sample problem 10.8. A company has just patented a new synthetic alcohol for alcoholic beverages. The new product is said to have all the pleasant properties associated with ethanol, but none of the undesirable effects such as hangover, impairment of motor skills, and risk of addiction. The chemical formula is proprietary. You analyze a sample of the new product by placing a small volume of it in a round bottom flask with a volume of 510.0 milliliters and an evacuated mass of 131.918 grams. You submerge the flask in a water bath at 100.0 degrees Celsius and allow the volatile liquid to vaporize. You then cap the flask and remove it from the water bath. You weigh it and determine the mass of the vapor in the flask to be 0.768 grams. What is the molar mass of the volatile liquid? And what does it mean with regard to the new product? Assume the pressure in the laboratory is 1 atmosphere, okay? So here's the idea. What you do is you have a flask. And you put a little bit of liquid in there. You then attach it. Actually, let me take that back. You then put it in a container that has water in it. And then you heat the water with a flame. There's a little cap here we're going to put with a tiny little hole right there. Okay, so what happens is when you heat water, eventually it reaches 100 degrees Celsius and it starts to boil, at least if you're at sea level. So that means the water bath is 100 degrees C. So that means the contents inside the flask are also at 100 degrees C. Okay? And what will happen is it's volatile, which doesn't mean it'll explode. Sometimes people think volatile means it'll explode. That's not what it means. Volatile means that it will vaporize. It will become a gas. If it is a gas, it may very well obey the ideal gas law. Okay, so now this flask here has a gas at 100 degrees C. It also is open to the air. It's an open system. So that means the pressure is the same as the atmospheric pressure, which is 1.00 atm. And what do? They measure the volume of the flask later on. And they find that it's 511.0 milliliters. Okay? So you have the temperature, pressure, and volume. What that allows you to do is to find, using the ideal gas law, the number of moles of gas. Okay? The number of moles of the gas, if we divide both sides by RT, is equal to PV over RT. So that would be equal to 1 atmosphere .511 liters. I'm going to convert it into liters as opposed to leaving it in milliliters. R is the universal gas constant, 0.08206 atmosphere liters per mole Kelvin. Temperature is in Celsius. We want it in Kelvin, so we add 273.15 and we get 373.15 Kelvin. Okay? That gives us the number of moles of gas in the container once it's at that high temperature. So an atmosphere times 0.511 liters over RT. Okay? So an atmosphere times 0.5, let's try that again. An atmosphere times 0.5110 divided by RT, so divided by 0.08206 times 373.15, and you get 0.01669. So 1.669 times 10 to the minus 2. So that's how many moles of the gas there are. Okay. We're trying to find the molar mass. The molar mass of any substance is the mass of the substance divided by the number of moles of the substance. That's what the molar mass is. We're used to calculating it from the periodic table. That's 1 mole. So we're saying what's the mass if you have 1 mole. But if I don't have 1 mole, I can still weigh the mass, measure the mass, and figure out what the molar mass is. You just take the ratio of the mass of the moles. How do we find the mass of this vapor? Very clever what they did. Here's what they do. They evacuated the container, meaning when it's empty, the container has a mass of 131.918 grams. Okay? Then they essentially add the liquid, boil some of it off, and what they do is they eventually find that the mass of the vapor here plus the mass of the flask, they measure that. Okay? Then they take the difference. They take whatever this weighs together and they subtract what it weighs empty. Now they don't have you go through the calculation, but essentially what happens is they find that the mass of the vapor is 0.768 grams. Now in practice what you do is you then cool it back down to room temperature, and then you weigh it again. You can have less liquid than you started off here because some of it boils off when it's a gas. But if you cool it back down to room temperature, that gas will recondense back into a liquid, and that amount of liquid will be less than it was at the beginning, but you'll still have some liquid there, and you weigh it again at room temperature. So they've figured out what that mass is, 0.768 grams. So that means the molar mass is the mass over the moles. So 0.768 grams divided by 1.669 times 10 to the minus 2 moles. Okay? So I'm going to do a little trick here. I'm going to divide our previous answer, the number of moles, by 0.768. And you'll say, no, that's not right. We want the mass over the moles, not the moles over the mass. Okay, so I'll take the reciprocal of it. I'll just do the 1 over x, if I can find it here on the calculator. There it is, 1 over x. And you get 46.02. I'm going to round that to 46.0. And there you go. We have figured out the molar mass of this substance. 46.0. Okay?